Very good morning to all. Uh, Today, we are going to see about the basics of database management system concepts in relational algebra concept. So, our subject code is 20 CS 402 database management system. So, before that, we need to know the objective of the course. Why we need to study this course? So, to study the fundamental of data models and SQL. So, through this, through the first objective, we may know the different data models available in the database concepts like entity relationship model, relational model, and semi-structured model, object-based model. So these are all things present with that first objective. And the second objective, database system using a ER diagram. When you are going to design any database system, we need to design this. We need to design a template. For that template, we are going to use entity relationship diagram. So this is what we are going to. So these are all things we are going to see in the second unit. So the third objective is to understand the fundamental concept of transaction processing, concurrency control techniques, and the recovery procedure. So through that, what do you mean by transaction? In the transaction, what is the property of what are all the properties of atomicity? Acid we'll discuss all acid properties and other different techniques present related with transaction processing. And the fourth one, the knowledge about storage and query processing techniques. And finally, we'll go with some advanced database management concepts. So here, these are all some topics. So out of that, we are only see about relational algebra. So the relational algebra, a procedural language which is used to access database, to read tables, to read data in different ways. So through the relational algebra, we may read different data from different databases. So here it is performed by using of operators. So that is the symbols. Through the symbols, we can retrieve a data from different location. So each relational query describes a step-by-step procedure for completing the desired answer based on the order in which operators are applied in the query. So here some of the relational algebra operations: selection, projection, Cartesian product, union, set difference. So we will first start with a selection operation. So for that selection operation, we are going to use a sigma. So by using of these sigma's operator will fetch rows based on the prediction. So the prediction is nothing but the condition. So predict to fetch rows or a table from the table. So here it is a syntax sigma. So sigma, it denotes the selection operation. Predicate, so the predicate denotes that condition what we are going to apply with the table. And a relation, so relation is nothing but it is a table name. So predicate denotes the logic using which data from relation is selected. So this is a basic example. So here we'll have a student table with attributes of a register number, a student name, and age. So we'll have a three different tuples with the register number of 1, 2, 3. So here we are going to select tuples with a condition of sigma, age is greater than 15, and student. So here, when you're going to check this table, it is going to fetch data which are all the tuples age with a greater than of 15 value. So out of this table we'll get two different two different tuples. One is a register number 2 and register number 2. Why? Because the age of register number 2 is 18 and the age of register number 3 is 16. So what is the result of the syntax or the query is it will give you the result of register number 2 and register number 3 tables. And the projection, to project only a certain set of attributes. So what is the difference between selection and projection? Through the selection we may get rows, but instead in the projection operation we'll get a column to project only a certain set of attributes of a relation. So when it is going to retrieve a column, it is also perform another operation called removing the duplication. So duplication from the column system works. So here we are going to use a symbol called pi. Pi a1 a2 are attributes, are the column, or a data field, or is a relation. So here again we'll go with the same student table, register number 1 2 3, serial student name ABC, age 15 15 18 16. So here I'm going to fetch a age attribute or age data field. So when you are going to perform age by age student, then it is going to retrieve a age attribute. So what is the result? It will give you the final result of age and union. So union is another kind of relational algebra operations. So to fetch data from two relations or temporary relations. So the relations specified should have a same number of attributes and the same attribute domain. Duplicate tuples are automatically eliminated from the results. So here we are using union symbol as A union B. So here we'll have a two different table, A1, table A1 and table B1. When you're going to combine A1 and B1, it will going to combine and it removes the duplicate value. Okay, set difference. So here we are going to remove the result of a set difference is tuples which are present in one relation but are not in the second relation. Will only give what are all the relation present in a one relation. So it is happen in the set difference. So here A1 table A1 table B1. So A1 minus B1. So when you're going to perform a set difference, A1 minus B1. So here in a B will have 1 2. So we just remove 1 2, and so we finally has a table value of 1 1 and 2 1. So Cartesian product. So we are going to combine two different relation into fetch some combined results. So though by using of these two table, when you are going to combine these two tables, we'll get results like this. So likewise, we may see a more number of performance. Thank you.